This is section 3.8b, using formulas in a real-world setting. Here we're given information about a formula. We're told that the fuel economy is represented by E. We're told that the formula itself here is capital E equals M over G. We're told that M is the number of miles driven and that G is the number of gallons used. So this information sets up a formula for us, and that formula is E equals M over G. Now we're told to take that formula and solve it for M. To isolate this M, I have to get rid of a G. Well, the G right now is connected with division. To remove division, I'm going to multiply both sides by G. Now I'm going to write this left side as capital E G equals, the G's over here will cancel, leaving me with an M. So if I simplify that and put the M on the left, I get M equals EG. I have just solved my formula for M. Now I'm going to use that formula to answer the question down here. It says if Claudia's car has an average fuel consumption of 30 miles per gallon, she uses 9.5 gallons, how far did she drive? Well, M is miles driven, so that's the part that we do not know, and that's why we isolated it, because that's what we didn't know. We're told the fuel consumption is 30 miles per gallon. That's going to be my capital E. So I'm going to substitute a 30 in for the capital E, and I'm told that she uses 9.5 gallons. And I'm told up here that little g is the number of gallons used. So that's going to become a 9.5. 30 times 9.5 is 285. So M equals 285, and that represents miles driven. So you can see that I can have a formula, and if there's one value that I do not know, in this case I did not know the M, I can isolate the M and then plug in the values that I do know to solve for the M in this case, or any value that we don't know. In this section we learn about a new concept, a new vocabulary word, and that is dimensional analysis, the process of carrying units throughout a computation. What that means is when you have a problem or a computation that involves units, like 50 miles or something like that, rather than just using the 50, you actually include the M for miles, and you include that in the computation, and you do everything you would do with the number, also with the letter. Maybe 24 seconds is an example. And so in the problem you use 24 seconds. And if you're told to square 24, you not only square the 24, but you square the S. And by doing that, you end up with a new unit at the end of the problem, as you'll see in our next example. This is an example that we'll use to not only review how to use a formula, but also to do some dimensional analysis here at the end. This is in your book at page 167, example 4. We're given a formula here, and we're told that S is the distance that a free-falling object will fall near a planet or a moon. That's what S is. T is a time, and then A represents the acceleration due to gravity. We're told to solve the formula for A, so we're going to do that now. First thing I'm going to do is I'm going to remove this 1/2 by multiplying both sides by 2, because that's the reciprocal. And so we'll have a 2S equals the 2, and the 2 will cancel, so A times T squared. Remember, I'm solving for A, so I want to isolate that. I want to remove the T squared, which is currently being multiplied. To remove that, I do the opposite, which is divide both sides by T squared. So that's going to cancel, leaving my A by itself, and I'll put that on the left side. And on the right, I'm going to have 2 times S over T squared. So I have now isolated my A in the formula. Now I'm going to use my formula to answer this question down here. It says a free-falling object near the moon drops 20.5 meters. That's a distance, and so I'm going to end up putting that in for my S, because I was told that S represents distance. In 5 seconds, that's time. I was told that T represents time, so I'm going to plug that in for the T. And then what is the value for A on the moon? So that's what I'm going to use. My formula is A. The number 2 remains a 2, but now for S, which we set up at the top, represents the free-falling object, the distance the free-falling object will fall. So I'm going to use the distance of 20.5. And now I'm going to include the units. I'm going to use the word meters here. This is dimensional analysis. This is when you include the units in your actual computation. And rather than just use an M, that might confuse you, I'm actually putting the whole word in so you know what I'm doing. Then we'll divide by t squared. I'm told that t is time. My time here is 5 seconds. Again, I'm going to use dimensional analysis and include the units. And because it's t squared, I'm going to square that. And the interesting thing is not only is the 5 need to be squared, but so does the units, the seconds. 20 times 20.5 is 41. The units stay there. So 41 meters over 5 squared is 25. And you also have to square the units. In this case, seconds squared. Continuing, I have to divide these. 41 divided by 25, 1.64. And now my units are going to be meters. I'll use an M for that. Per, I'll use a slash, per seconds squared. So those are my correct units for the number. So the value of A is 1.64 meters per second squared. I can use dimensional analysis by keeping the units involved in the computation and carrying them to the end. Here's another example of solving using a formula. We're also going to use a dimensional analysis here. This is on page 168 in your book. We're told to find the area of this triangle. We're given the formula, the area 1/2 base times height. And we're told the base is 18 feet and the height is 7 feet. I'm going to use dimensional analysis here. And instead of just putting 18 in, I'm going to put 18 and the units. I'm going to put feet. And then times a height. So we'll put 7 feet in for the H. All right, now using algebra, 2 goes into 18 9 times. So cross canceling. So we end up with 9 times 7, which is 63. But here's where dimensional analysis comes in. Feet times feet is feet squared. Just like x times x is x squared. So we have our proper units. The area of this triangle is 63 feet squared. Now question number 11 says to solve the formula for h. I'm going to do that by multiplying both sides by 2 because I want to eliminate the 1/2. So we'll get a 2 times a equals, these 2's will cancel, b times h. The b is connected with multiplication, so I can divide. So isolating the h, I get h equals 2a over b. And then question number 12 says, what's the height of the triangle? I can use this formula that I just solved with the h for 2a over b. I'm going to use that. I'm told the area is 28 square feet. I'm going to use dimensional analysis here. And so for area, I'll not only put 28, but I'm going to put feet squared. You'll see how we deal with that in a minute. And divide it by the b, the base. We're told the base is 8 feet. Again, with dimensional analysis, I'm going to include feet. 28 times 2 is 56 feet squared over 8 feet. Now I'll do the easy part. That means my height, 56 divided by 8 is 7, so I know it's going to be 7 something, but what's the unit? Dimensional analysis says feet squared over feet. But what does that mean? Feet squared is nothing more than a foot times a foot. This is how you write it if you write it out. Feet squared is feet times feet, and then over feet. So I'm going to cancel off one set of those, leaving my proper unit behind, 7 feet. So the height of the triangle then is 7 feet. This is the answer to number 10, number 11, number 12.